All right, when you're looking to factor, there's a set of steps that you or progression that you should do when you're factoring. So here is the progression. Step one, which you saw in the last thing, which is to remove any common factors first. That's always the first step. Look to remove any common factors. Okay, once that's done, you can move on to the next step, which is to find any special factor forms. Okay, the special factor forms themselves are kind of based on the number of terms that you have in your expression. Okay, so if you're looking at an expression with 2 terms, okay, the special factor forms that you should be considering are the difference of squares, okay, if that doesn't work, the sum and difference of cubes, and for the most part, those are the special factor forms that you'll see with 2 terms. Okay, if you have 3 terms in your expression, then you should consider looking for the perfect square trinomial form. Okay, or you can reverse FOIL in order to complete the factoring steps for 3-term expression. If you wind up with 4 terms, then what you're going to do is you're going to use factor by grouping. Okay, so if we follow this process here through this sample problem. All right, so the first step is remove any common factors. Are there any common factors we can remove from this expression? No. So the next step is to apply special factor forms. So we have 4 terms here, so we can jump all the way down and look to factor by grouping. Factoring by grouping, if you recall from the reverse FOILing process, the alternate to that, the rewriting the middle terms, and it can be done by grouping the first and the last pair of terms together as a group, and then removing any common factors from each group. So if we look at just this first pair of terms, what common factor can we remove? X squared. And when we remove an x squared, remember, removing it or factoring out is kind of like dividing it and seeing what's left. So when we divide x cubed by x squared, how many x's are left? Just 1. So x to the first. Plus, when we divide x squared by x squared, what is a value of something divided by itself? 1. So there's what's left in that first group. Do the same thing with the last pair of terms. What common factor can we remove?
-4.
Take out that -4. When you divide a -4x by a -4, what's left? Just the x. And when you divide -4 by -4, you're left with +1. Be careful of any negative signs when you're removing common factors like this. Okay, once you get to this point, what you should notice is your binomial factors should be identical. If they're not, then it doesn't factor. Or you've done something wrong. If they are, which in this case they are, remove those as its own set of common binomial factors, and then whatever's left inside creates and becomes the 2 terms of your other binomial factor. So x squared minus 4 become the other binomial factor. Now, here's the one thing to keep in mind when you're going through this process of factoring, and that is when you get to the end of this, you might need to repeat it all over again. Because now look at each individual factor. If you have any factors with a higher degree than 1, so any powers of 2 or more, and you need to consider factoring those. So the x plus 1 can stay. It's a first degree factor, and you don't need to go any further with it. But the x squared minus 4, we need to come back and go through this whole chain of instructions again. So can we remove any common factors here? No. Apply the special factor forms. There's 2 terms in this factor. So is it a difference of squares? Yeah. So what we can do here is we can take this x squared minus 4 and we can factor it even further. What are the two bases that are squared to give you those terms? X and 2, so it factors into the sum and difference of those, and that would be your final solution. All right, so I want you to try the following one. Example, please. All right, so see if you can come up with the fully factored form of this expression, please. All right, so let's talk through this, the process of factoring. All right, so the first step is to remove any common factors. What common factor can you remove from these two terms? Take out a 4. And you can also take out a x. Okay, so there's your common factors. When you do that, when you remove a 4x from the first term, you're left with x cubed. You took out the 4 in one of the x's, and in the second group, you're left with 27. So you have x cubed minus 27. So now we cycle it back here. We look through. We look to apply any special factor forms. We do have two terms in this binomial factor here. Does it fit the difference of squares? No. What about sum or difference of cubes? Yeah, it fits that form, right? So the 4x is going to stay as it is. It is a difference of cubes. Okay, so if you look at this, the two bases that are being cubed, you have an x being cubed, and you have what being cubed? A -3. So when you look to factor this, it has a binomial and a trinomial factor. The binomial is just the sum of those bases, so x and a -3. And then the trinomial is the first base squared, so x squared. The last term of the trinomial is the second base squared, so -3 squared is +9. And then if you take the product of those two bases and change the sign, you get your middle term of that trinomial. So x times a -3 is -3x. Change the sign, +3x. And that gives you your final form, or your final solution. Okay.